Hello and welcome to this section of the Algebra Tutor. In this section we're going to talk about natural number exponents. It's kind of a broad sounding title, but basically what we're going to do in this section is learn how to work with exponents above and beyond what we've already talked about to help us simplify expressions. You know, most of algebra, to be honest with you, is learning how to simplify expressions. And a lot of students, when they start seeing exponents running around, you know, x to the 5, x to the minus 3, and other exponents everywhere, they just kind of freak out a little bit for no reason because it seems foreign to you. Until you get to algebra, you haven't dealt with exponents a lot. And exponents are everywhere in algebra. So, you know, a lot of students get uneasy. They don't know how to simplify. They don't know how to combine terms with exponents and things like that. We've talked a little bit about this in previous sections, but here we're going to just punch it in the face and really get on top of exponents and go over every little detail of how you simplify these things. I'm not going to lie, it's a little bit of a long section. So make sure if you have to take a break or whatever, go ahead and pause the video and do that. Make sure you can do everything and understand everything in this section. I promise you it will make your life easier as you go on. And the good news is, I'll promise you when I tell you this, it's not hard. Let me just teach you the steps and we'll go from there. So let's do a little bit of a review. Let's crawl before we can walk. All right. And so we'll do a little bit of a review. When we have something like 5 raised to the power of 3, then we already talked about the fact that what this is basically saying is it's 5 times 5 times 5. We multiply the 5 by itself, the number of times that the exponent represents. So it's a shorthand way. Instead of writing all this multiplication out, it's a shorthand way of writing multiplication. So when you see exponents, try not to think, oh no, that's a crazy looking algebra thing. Think, that's just multiplication. That's all that exponent is. So hopefully break down, you know, some fears if you have any of those. If you have anything like, you know, negative 4x raised to the power of 5, if you were going to expand this out, it would make it negative 4 from the front times x times x times x times x times x. I've multiplied x times itself 5 times because of this. And then the negative 4 is also being multiplied by the whole thing, so it's just kind of sitting out in front. So wouldn't you agree that taking this, writing this out is kind of cumbersome, so we have this nice shorthand way of writing the same thing. If you had something like negative 2y raised to the 4th power, that's negative 2y times negative 2y times negative 2y times negative 2y. And anytime you see parentheses just sitting next to each other, it means multiplication. We're multiplying everything inside the parentheses, which is negative 2y, times itself 4 times. So everything in here is raised to the power of the 4. All right, now let me get to the first thing that we're really going to learn in this section. What if you were simplifying something like x to the 4th multiplied by x to the 3rd? All right, so you want to simplify that. Now, we already learned how to add and subtract exponents, right? And or I should say terms that have exponents. And we said the only way you can add or subtract them is if everything matches, the variable matches, the exponent matches, then you can add the numbers in front. But when you're multiplying exponents, it's almost easier because really all you do is you keep the bottom thing, the x, and you just add the exponents together. So what you'll get is x to the 7th. That is the simplification or combining these things together into one thing. And when you think about it, I'll show you how this makes total sense. Okay? Because what you really have here, this x to the power of 4, this is basically x times x times x times x. That's what it is, 4 times, 1, 2, 3, 4. And it's multiplied by x to the 3rd power, which is x times x times x. So I put the parentheses here just to kind of show you that this goes with this and this goes with this. But really, you don't need parentheses here. Everything's multiplied together, so I could kind of take them off if I wanted to. Everything's multiplied together, so the parentheses don't really matter much. So what do I have here? I have x times x times x times x times x times x times x. So I have x multiplied by itself 1, 2, 3, 4, 5, 6, 7 times. And that is why we add the exponents together. In order to add exponents, the base, which is the x in this case, they have to be the same. So x matches with x, so we keep the base the same, right, which is everything we're multiplying together, and we add the exponents together. Because ultimately, this is what's happening. All right? What if you had x to the 5 times x to the 5? First thing you check is you see, are the bases the same? I have x and I have x, so yes, I can multiply these together. I'm going to add the exponents and I'm going to get a number 10, right? X to the power of 10. I just add them. And again, if you wanted to convince yourself of that, this is x times x times x times x times x, right? And this is all multiplied by, I'll put a big dot here to represent that it's multiplied by the next thing, x times x times x times x times x. Everything's multiplied together, so really, I have x to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 power. So that's why you add exponents together. There's always a reason behind it. All right, so let me go and erase the board and we'll continue building on what we've learned here to go inch our way to the more complicated problems. All right, what if you had y to the power of 3 times y squared y to the 4th power? And you wanted to simplify that. You're typically taught to do everything inside of the parentheses first. So let's go ahead and do it that way. The y to the 3rd, we could just leave it out for now. And inside, we have the same base, which is y. So we can multiply these guys together and add the exponents. 2 plus 4 is 6. We'll have y to the 6th. Now notice that we're just multiplying these together. And again, I have y here and a y here. So I can keep the base the same and I can add these exponents. 6 plus 3 is 9. So that would be y to the 9th power. So basically, anytime you're multiplying things that have exponents, when you're multiplying variables that have exponents, you can combine the exponents together by adding the exponents only if the bases, in this case y, match perfectly. All right? Let me change colors here just to break it up a little bit. What if I have 4x squared times 3x to the 5th? Something like this. What if I have that? All right. Well, what you have going on here is multiplication. The 4 times 3 is still going to stand, so you're going to have 12. But just to keep it clear, let me write everything else out. I'm going to have 12 times x squared, and I'm still going to have the x to the 5th. Basically, I multiply the numbers, but everything else, let me just kind of keep along for the ride so you can see what I'm doing. Now you can see I have x and I have x, which match. I can add these exponents. So 12x, 2 plus 5 is 7. So 12x to the 7th power. So we're inching our way forward, doing problems that are a little more complicated each time. What about negative y squared times 4y to the 3rd power? How would I simplify that? Well, I have a 4 times this negative 1. So I'm going to have negative 4y squared times y to the 3rd. I'm just hanging on to these because I just want to do everything in separate steps. The negative 4, the y's match, so 2 plus 3 is 5. I can add them together. If this were not y cubed, if this were like x cubed, then y squared times x cubed, I wouldn't be able to add them. I wouldn't be able to combine them. I'm only able to do it because the base, which is y, is the same in these cases, in these problems. And we'll get to some more problems in a minute where we'll not be able to combine them together. But for now, let's say we have something like 6x cubed times negative x squared times negative x to the 4th power. So we're getting a little more complicated each time, but not too bad because when you really look at what we're doing, we have a 6 times a negative 1, and this is also a negative 1. Basically, all of the numbers, if everything's multiplied, the numbers can be multiplied. So negative times negative gives you positive. We're still going to have a 6. Let's just keep our variables along for the ride now. Basically, the negatives went away because of the multiplication. Now when we look here, we see, well, we have x cubed, x squared, x to the 4th. X is the same in each case, so we can keep that along. And we can just simply add the exponents together. So 3 plus 2 is 5. 5 plus 4 is 9. So we have 6 times x raised to the power of 9. All right, so not too bad. And keep in mind, we're only able to combine these guys because the base here, which is x, is actually the same. So let me give you an example to illustrate that. What if you have 12x squared times y to the 9th? And I said, simplify that. Well, you should look at that and say, well, there's nothing to multiply. 12 is already there. I have x squared and y to the 9th. These are different animals. This is x times x, and this is y times y times y, all the way doing it 9 times. There's no way to combine x squared and y to the 9th. So you just say can't simplify. Or you could just write already simplified or already simple form. You can't do anything more with it this is it. You can't simplify this anymore because you can't combine things that are different.